Okay, so let us show the REDI reactive robot, and we'll be using the line sensor, which is this array of infrared sensors beneath. And this output here senses the position of a black track on a white surface, and it goes all the way from -100 to 100. When we connect this to the motors, when that situation, we have action. So let us start. What we need is that the robot that is centered on the line to go straight. So we will have to use this constant here and the sum function, and then do some kind of negative feedback, so that if the error is to one direction, we just make the two motors react in opposite directions, so that the total velocity, translational velocity, is kept constant. So let's start. So we have a constant here, and we just plug it in to a sum, and we have the other sum function, and from the output of the sensor we will do some multiplication so that we can have a definable proportional gain, and from the output we are going to connect to both summers, and one of them is going to be inverted, and then the actual result of the sum is going to be sent to the motors. After the product, we are going to have the output of the product to go back to the summing function, and from the result of the summing function we connect to the motor. On the other side, it will be something similar, but by means of the inverter. So we have here the output of the product function, we connect it to the inverter, and from the output of the inverter we connect to the addition function, and from the addition function we will just connect to the other motor. When we connect the robot, we turn it on. I'm just gonna hold the robot steady and press start, so we can see that all the lights are actually working well and there are no bad connections. So all the LEDs are on. And now we'll head on to the track and see how the sensor works. To configure the offset so that the robot moves forward slowly, and configure the gain, and these values are going to be, well, useful. So let's head down to the track. So we already placed the robot over the track, and we can see clearly on the front the LEDs of the sensors that are active, that are seeing the black, and you can see the robot just correcting so that the line is aligned with the center. If we want to make the robot go faster, we need to change the parameter of the K so that it will in fact go faster, but most likely we will have the robot losing itself because it is a rather large robot. Let me just stop the robot. I'm going to increase the offset. And we'll see the robot running faster and wiggling because we have a faster gain, so that the robot is still following, but he will most likely end up losing itself because we put the robot just going too fast. Okay.